In this video, we'll be proving sine x to the 6th plus cosine x to the 6th equals 1 minus 3 times sine squared times cosine squared. So the first thing we're going to do is rewrite sine to the 6th as sine squared cubed and cosine to the 6th as cosine squared cubed. And now we want to look at the sum of two cubes. Well, if we have a cubed plus b cubed, that's the same thing as taking quantity a plus b and multiplying it with a squared minus ab plus b squared. Here a is sine squared and b is cosine squared. So we're going to replace sine squared and cosine squared in the formula. So we'll get sine squared plus cosine squared, and then multiply that by sine squared squared minus sine squared times cosine squared plus cosine squared squared. Now sine squared plus cosine squared is 1, so that goes away. And then we'll replace sine squared squared and cosine squared squared with sine to the 4th and cosine to the 4th. Okay, so now we have sine to the 4th minus sine squared times cosine squared plus cosine to the 4th. Now, this is on the side. If I was to look at sine squared plus cosine squared squared, that'll be sine to the 4th plus 2 times sine squared times cosine squared plus cosine to the 4th. And so if we solve for sine to the 4th plus cosine to the 4th, we would have to subtract the 2 sine squared times cosine squared. And so that's what we're going to need to substitute in the equation above. So sine to the 4th plus cosine to the 4th, well, sine squared plus cosine squared is 1, so that's 1 squared minus 2 sine squared times cosine squared, which simplifies to 1 minus 2 sine squared times cosine squared. And now we can take that and replace it with the equation up here. You have sine to the 4th plus cosine to the 4th. That's going to be replaced with 1 minus 2 sine squared times cosine squared. And so you have negative 2 sine squared cosine squared minus sine squared cosine squared. That can be simplified into negative 3 sine squared cosine squared, with the 1 being in front. And so this completes the proof.